Hello, everyone. Welcome to the second set of slides/lecture for week 2. We'll be focusing on the supply function, things that shift the supply curves, and talking about unemployment to demonstrate the usefulness of understanding supply. So just to get an idea of the historic reduction in employment that we're seeing due to COVID-19, this is a graph of all recessions and the amount of job losses in each one compared to peak employment right before the recession happened. And you can see that this red line here for the COVID-19 employment recession is much larger than any other recession that we've seen in employment. So we really want to understand these things. And there's a lot of economic dimensions to COVID-19 pandemic and how it relates to current employment, which you can click on these to understand more. But just some summaries from that is, we know that benefits disincentivize work, or unemployments do, because if you pay somebody for not working, then they're less likely to seek work. And this is especially close to me because when I ran my fireworks tent, I tried to get my friends to work, and it was really hard to get them to help me out. And I realized that part of that might have been because at least a few of them were receiving unemployment benefits. And something that might happen is employers might look less. So because I know that people are getting benefits, then I might just be like, well, screw it, it's gonna be too hard to find somebody anyway. And the larger this disincentive effect is, it implies that the optimal amount that somebody receives in unemployment benefits should be lower. Right now, the evidence has only been that there's a small disincentive effect. That is, it's not really affecting job seeking that much, but this could grow over time. And it's been shown in other contexts that there are large disincentive effects to unemployment benefits, and whether or not those generalized to our situation now is debatable and empirically testable. So there's many other views there that you can check out if you want, if you click on the link. But otherwise, there's been some research on the disincentive effect in COVID already and how people are spending their stimulus payments. So those are kind of important for thinking about how to calibrate an optimal unemployment benefits policy. And we know that worker separation from their jobs could be harmful, and there's some research going on about that. Unemployment benefits affect the macro economy. So if you're more interested in macro issues, well, if people aren't getting benefits, then they can't spend, and that affects consumption, that affects GDP, et cetera, et cetera. And then COVID-19 really touches a lot of areas of economics that you can see here if you click on this and download the slides that Justin Wolfers has put together for his principles textbooks. So just talking about exactly how employment and supply are related. This is a supply curve we have here on the right, and we could just use this to model labor supply as well. So this is what that looks like. All I did was change price to wage over here, change quantity to quantity of hours supplied here. You can see that I put labor in parentheses. And all that's happening is that this model predicts that higher wages per hour leads to greater hours worked or supplied. And so if you go from like 5 to 15, then boom, more hours are supplied. So this actually is closely related to how a business would think about supplying a product. And I want to make that explicit for you. So marginal cost is just the cost of providing the next unit, or say hour of work in this case. And all this increasing curve says is that to give up the next hour, it costs more for you to decide to give up that next hour. Average cost is just the cost divided by the total amount that you produce. And so it's slightly different than marginal cost. But I'm going to leave average variable cost undefined for now. We'll get back to that later. So this break-even point right here is just at a price higher than this break-even point, you're making economic profits. And at points below the shutdown point, or prices or costs or wages below the shutdown point, it's suboptimal to provide hours of work or produce a product. And because of that, if the wage is below this reservation wage, then you just decide not to work at all or not to produce any product at all. And so this is from OpenStack's microbook, this image right here. And all I did was draw in that the point above this minimum average variable cost curve is the firm supply curve. Or, and said another way, wages above this wage are where quantity supplied of hours of work are greater than 0. And I'll show you that in the supply curve. I just want to talk about this is assuming that the break-even point equals a shutdown point, which is just simplifying our discussion by taking away fixed costs. And this is a general labor supply curve that we saw already, which can be written quantity supplied equals alpha plus beta times wage. Now, let's assume, or let's say that wage is like 0 for now. And so where this touches the y-axis, or at the value this touches the y-axis, is alpha. Beta is essentially, or influences, the elasticity of supply. Steeper lines mean higher betas, and higher betas mean that you're less price sensitive. So you would, if it was steep, if it were completely vertical, you would supply the same amount of hours at any wage. And I just point out this is inverse supply curve. So some of the it can be mathematically complicated to plug in numbers and get the right thing. But going back to the shutdown point, I'm going to add some numbers into this to reduce some of the abstraction for you. So let's say alpha is 5. So at 5, you supply 0 hours. And at alpha, the wages are not high enough to cover the leisure that you could get from giving up an hour of work. And so basically at $5 or anything below $5, you're not willing to work at all because it doesn't cover the cost for you of getting out of bed or driving to work, etc. So if wages fall below 5, then you're below your labor shutdown point from the earlier graph. And it becomes optimal for you to supply 0 hours or in firm production produce nothing. There are other determinants of supply, which would be represented as a parallel shift to this curve. And the 4 things that we think about shifting these curves are right here, and I'll go through each of them in detail. So prices of inputs, more expensive inputs reduce supply, less expensive inputs increase supply. Oil is a classic example of an input that is important for a number of things because it gives you energy. And so more expensive oil will reduce supply, whereas less expensive oil increases supply. From a labor supply perspective, if it becomes cheaper to drive to work because gas goes down, then that'll shift your labor supply curve outwards. Technology, so better technology increases supply. It represents more efficient production. You can create more with less or the same amount of inputs. And so an increase in technology is just you have a better way to combine your inputs to produce products. And so a quick point to make is that these are not computers. These are ways that computers combine, a hard drive and RAM to create an output like this video. And so computers are capital, not technology, but the operating system that combines the hardware of the computer would be technology. And so another one is expectations. If suppliers expect prices to rise in the future, they sell less now. This is a picture of lots of oil barges in the water where the price of oil collapsed in the 2014, 15, around that time, 16. Then a lot of people were letting boats stay at water as they waited for the price of oil to increase. And the final thing is the number of sellers. So if more sellers enter the market, the supply shifts outwards. So like when Chipotle came down, that shifted the supply of the downtown lunch market outwards. And if suppliers leave the market, supply shifts inwards. And this is the Dairy Queen on High Street before it was Clutch and RIP Clutch Winch. So one more thing is I showed you how quantity demanded. I just showed you how supply shifts. Now you need to see what happens when the wage or the price changes, which does not shift the curve. So supply refers to this entire curve, while quantity supplied refers to specific points on this curve. So quantity supplied at price or wage equals 7 is quantity supplied equals 10. So I'm going to do some theoretical analysis of unemployment benefits now. Let's say we have the nationwide market for service industry labor. Let's assume there's no minimum wage to simplify our discussion and make our point. And let's assume that the labor market fulfills conditions for perfect competition, so it can be modeled in this supply and demand framework. All right, so let's say that there's no price intervention, no minimum wage. So through this bargaining process, the price or the wage gets bargained towards this equilibrium price and quantity. And now let's put some labels on that. Let's say, so like the equilibrium wage is $1,000 and the equilibrium quantity of wages or labor supplied is 1,000 hours. Now let's pretend that we get a COVID shock to this market. And so after the shock, when restaurants have to close down, they immediately demand less labor because they can't serve as many people if they have to shut down. And the shock is so sudden that wages cannot adjust in time. And part of the reason for this is that contracts are sticky, wage contracts. So your employer can't just say, oh, I'm deciding to take your wage down from $7 per hour to $5, so they just fire you. And so at price equals 1,000, which we were at before the COVID shock, afterwards, the price is still staying at this 1,000. The reason for that is those sticky contracts. However, while the labor is supplied for this for this wage, people want to work 1,000 hours. Now restaurants are only demanding 750,000 hours of work. And so now there's still this much supplied, but only this much is only this much labor is actually needed by restaurants. And so zooming in on these 2 points, we can use these to calculate the amount of unemployment that happens due to coronavirus. It's the difference between point B and this equilibrium quantity, which is 1,000 minus 750, or 250,000 hours of unemployment, which is signified by this part of the labor supply curve turning red. These people are unemployed now due to the coronavirus. And so when we're thinking about unemployment benefits, this is one way to think about maybe what the right amount and level of compensation would be appropriate. And then one other issue with unemployment benefits is if you're a federal policy maker, the regional labor markets might be different. And I'll show you this through an example. What should you set unemployment benefits at? You need to set it high enough to help people get through the crisis. But the drawback, as we mentioned earlier, is that higher unemployment benefits lead to a greater work disincentive and can also hurt the federal budget. But I don't want to get into that too much. And so let's say New York City and Preston County, West Virginia are 2 examples. These 2 places have much different labor markets and probably much different equilibrium wages and quantity of wages and quantity of labor supplied. And so if you see a lot of like TV boxes after a stimulus check, is a hint that maybe the benefit was high relative to post-corona market wage. And I don't know, I saw lots of these in South Park, but I'm just pointing out like something that could happen. So let's compare these two regional labor markets right here. Preston County, equilibrium wage is 9 and the equilibrium quantity is say 5. When you compare that to New York City, equilibrium wage is like 19, and we can say the quantity is 5 too. Maybe it's millions of hours for New York City and thousands of hours for Preston County. So what this shows is that if you create your unemployment benefits package to simulate kind of like an hourly wage of $15, in Preston County, it wouldn't make sense to work at all, because you can make, something like $9 an hour through actually going to work, or you can not work at all and make $15 an hour. Whereas in New York City, the unemployment benefit of $15 per hour doesn't really like substitute very well for what you had before, which would have been an hourly wage of like $19 per hour. So the benefits would be like kind of too small in New York City. And this is kind of like the hard complication of making federal policy for different regions. And so this is the conclusion. Supply function is just asking how much producers are willing to produce at each price. And our example throughout this set of slides was how much is an individual willing to produce hours of labor for somebody at each price, or in this case, in that example, wage. Several determinants of supply cause producers' willingness to produce to shift. So like if gas gets cheaper, then you're willing to supply, more labor at every wage because it's not as expensive for you to get to work. And then we kind of analyzed preliminarily what unemployment benefits look like and the regional inconsistency that can arise from using federal policy to make uniform unemployment policies for different regions. And so that's everything for this lecture today.